You've seen Venus shining in the sky. But what if I told you you've never truly seen it? These are real images, not CGI, not animation, taken from a planet so hostile it destroys anything that touches it. What you're about to see will change how you see Venus forever. For decades, Venus was a mystery, not because it was far away, but because it was impossible to see. Its surface is hidden beneath clouds so thick not even light can get through. No cameras could capture it, no telescope could pierce it. For years, all we had were guesses, until now, because what you're about to see is real. These are actual photographs taken by landers, scanned by radar, and captured by accident during flybys. Each one reveals a planet unlike anything we imagined. Cracked, burned, alive. This is not the Venus you thought you knew. This is the real Venus, unfiltered, unforgiving, and full of secrets still waiting to be uncovered. Venus is the second planet from the Sun, roughly the same size as Earth, almost the same mass. For a long time, scientists believed it might be Earth's twin, but when we finally tried to land there, we realized we were looking at something far more terrifying. In the 1960s and 70s, the Soviet Union became obsessed with reaching Venus, not flying by, not orbiting, landing. It was the most dangerous challenge in planetary science, because Venus doesn't just try to kill machines, it succeeds. Surface temperatures reach 465 degrees Celsius. That's hotter than the surface of Mercury, even though Venus is farther from the Sun. The pressure, 92 times higher than Earth's, enough to crush a submarine. And its clouds. They're made of sulfuric acid, not fog, not steam. Acid. The early probes burned up. Some missed the planet entirely. Others were torn apart before they reached the surface. But in 1975, after more than a decade of failures, something impossible happened. Venera 9 made it. It survived the descent. It touched the surface. And for 53 glorious minutes, it transmitted images. The very first photo from the surface of another planet. Black and white, warped, grainy. The camera was tilted. The view was strange. And yet, it was real. Rocks, broken slabs scattered across a cracked terrain. The horizon hidden behind haze. This wasn't a smooth alien desert. It looked more like a construction site. Harsh, uneven, and disorienting. But it wasn't a movie set. It wasn't a simulation. It was 38 million kilometers away. And we were finally seeing it. Just days later, Venera 10 landed 2,000 kilometers away and did it again. Another image. Another miracle. It survived longer, 65 minutes, enough to send more data from another part of the planet. The terrain looked similar, flat rocks, dense haze, cracks in the surface. Then came Venera 13 and Venera 14 in 1982. And that's when things started to get even stranger. Venera 13 didn't just take photos. It brought color, it brought audio, it drilled into the ground, and what it sent back was surreal. The sky wasn't black or blue, it was a deep, haunting yellow, tainted by volcanic gases and sulfur compounds. The surface, flat, interlocking rocks, like the overbaked crust of a pie, fractured, deformed, cooked by extreme heat. And through all that, you could hear faint sounds, wind, pressure systems, maybe even mechanical groans as the lander slowly died. Because none of these missions were built to last. They weren't rovers. They weren't orbiters. They were sacrifices, thrown into the fire to give us just one look. But that look changed everything. For the first time in human history, we weren't guessing. We weren't simulating. We knew. Venus wasn't Earth's twin. It was its evil sibling. Same body, completely different soul. And this was only the beginning, because while these landers gave us a taste of the surface, what lay beneath those endless clouds was still hidden. We had no idea what Venus really looked like from above, and what came next would shock the world. Venus is wrapped in a curtain of clouds so thick, not even light can escape. From space, it looks like a smooth yellow marble, perfect, blank, and completely featureless. For decades, that's all we could see. No mountains, no craters, no continents, just cloud. So scientists changed the rules. If light can't get through, then stop using light. Use radar instead. In 1989, NASA launched the Magellan spacecraft. It wasn't built to take pictures. It was built to bounce. Magellan sent radio waves straight into the Venusian atmosphere. The waves pierced the clouds, hit the surface, and reflected back. Those echoes were turned into images, not images of color or light, but of shape and texture. It was like feeling a planet with invisible hands. In 1990, Magellan entered orbit, and for the next 4 years, it did one thing over and over again. It mapped, patiently, relentlessly. By the time the mission ended, it had mapped 98% of the planet's surface in unprecedented detail, and what it revealed was chaos. Not the smooth planet we once imagined, but one torn apart by forces we still don't fully understand. Venus is covered in giant shield volcanoes. Some of them are bigger than anything on Earth. It has vast lava plains that stretch for thousands of kilometers, like frozen oceans of molten rock. It has strange features called pancake domes, round, flat, and miles wide, and fractured terrain that looks like a planet trying to rip itself apart from the inside. There are highlands, like Ishtar Terra and Aphrodite Terra, rising 11 kilometers above the lowlands. That's taller than Mount Everest. But what stunned scientists the most was the age of the surface. It looked young. Not thousands of years young, millions. Based on crater counts, Venus may have completely resurfaced itself just 300 to 500 million years ago. It's as if the entire planet melted and started over. Some areas were smoother than expected, others were shattered. Some reflected radar more strongly, hinting at different materials or more rugged terrain. But there was no mistaking it. This wasn't Earth's twin. This was a world stuck in violent geological motion, a world that didn't cool down, a world that reset itself, and might do it again. Magellan didn't just give us data, it gave us a new perspective. And with the help of computers, scientists turned its radar images into stunning 3D models. They added digital sunlight, created false color topographic maps. For the first time ever, we could fly over Venus. We could walk its shattered plains. We could stand on its burning mountaintops. But even after all that, something still didn't add up. Venus looked active, too active. The surface was young. But was it still changing? Was Venus still alive? That's when scientists decided to try something else. And what they found, they weren't ready for it. What if you could map the surface of a planet hidden by toxic clouds without ever leaving Earth? It sounds impossible, but that's exactly what scientists did. While spacecraft like Magellan were orbiting Venus, another group of researchers tried a completely different approach. They pointed massive radio telescopes at the planet and waited for the echo. This technique is called bistatic radar. One dish sends a pulse of radio waves to Venus. Another listens for the faint reflection. The signal travels across space, hits the surface, bounces back, and returns to Earth over 2 minutes later, barely strong enough to detect. It's like shouting at a mountain from across the ocean and listening for the whisper. But it worked. Telescopes like Unseeable in Puerto Rico and Green Bank in West Virginia generated radar maps of Venus, all from Earth. And while the resolution wasn't as sharp as Magellan's, the results were astonishing. They revealed real geological features, mountains, ridges, valleys, craters, volcanoes. And then came the surprise. Because these Earth-based systems could scan the same regions again and again, scientists began comparing the maps over time, years apart. And something didn't match. Some features had changed, not just noise, not just glitches, but real differences in shape, reflectivity, texture. In a region called Inoplania, radar images from 2012 and 2020 showed possible signs of surface change, a new lava flow, a subtle collapse, a shift in brightness that couldn't be explained by atmosphere or software. Something down there was moving. Even more strangely, these observations backed up what Magellan had shown decades earlier. Rough areas in Magellan's maps also reflected stronger radar from Earth. Smooth areas stayed smooth. Two completely different techniques. Same result. That kind of confirmation isn't luck. It's evidence. Venus was changing. Quietly, slowly, but undeniably. We'd never landed anything on 99% of the planet. We'd never taken a photo from those places. And yet, we were watching it shift from millions of kilometers away. The surface of Venus wasn't just visible, it was active. But even with radar, we still hadn't truly seen it, because light, visible light, still couldn't reach the surface. That is, until something unexpected happened. A spacecraft built to study the sun pointed its camera at Venus, and what it captured changed everything. The Parker Solar Probe was never supposed to study Venus. Its mission, to fly into the sun's atmosphere, closer than any spacecraft had ever dared. But to get there, it needed help. It needed gravity assists. And for that, it turned to Venus. 7 flybys, each one just a slingshot to reach the sun. But during one of those early passes in 2020, something strange happened. Engineers at NASA decided to try something no one expected. They pointed one of Parker's cameras, called Whisper, at Venus. It wasn't designed to look at planets. It wasn't optimized for low light. It wasn't calibrated for this kind of imaging, but they tried anyway. And what they saw broke every expectation. The camera captured something no one thought was possible. Parts of Venus's surface, seen in visible light. Not radar, not thermal imaging. Actual photons bouncing off the terrain, hitting the camera. But how? Venus's surface is so hot, it emits a faint glow, mostly in infrared, but also just enough in the visible spectrum. During Parker's nightside flyby, the contrast between the burning ground and the cold sky created the perfect conditions. And somehow, Whisper caught it. It wasn't high resolution, it wasn't clear, but it was real. Bright ridges, dark plains, shadowy highlands like Aphrodite Terra glowing faintly through the haze. It looked like a ghost, but it was there. The real surface of Venus, seen in visible light for the very first time. That one image changed everything. Suddenly, the idea of photographing Venus in light we could see was no longer fantasy. It was science. But Whisper didn't stop there. It also picked up something else. A faint greenish glow in the upper atmosphere, a halo of light from oxygen atoms, an air glow similar to Earth's auroras. All of this from a camera that wasn't meant to look at Venus at all. A solar probe, just passing by, caught something we'd been chasing for decades. And now that we'd finally seen Venus, a new question emerged. Was it still alive? And if so, could we prove it? For decades, Venus was considered geologically dead. No earthquakes, no eruptions, no tectonic activity. It was a burned-out husk of a world, a place where nothing moved, nothing changed, a fossilized planet frozen in time. But in 2023, something shifted. A team of researchers was reanalyzing old radar scans from NASA's Magellan mission, the same scans taken over 30 years ago. And hidden in those images, they found something that didn't make sense. 2 pictures, same location, taken 8 months apart. A volcano near the equator, Mont Mons. But in the second image, the vent had changed. The walls had collapsed. Its shape was different. And inside, what looked like fresh lava. It wasn't an artifact. It wasn't an error. Venus had erupted, not millions of years ago, not in theory, but within a human lifetime. It was the first solid evidence of modern volcanic activity on Venus. And it shattered everything we thought we knew about the planet, because where there's volcanic activity, there's heat. And where there's heat, there's movement beneath the surface. The implication was massive. Venus's core is still hot. Its mantle is still churning. It might even have hot spots, like Hawaii on Earth, where magma slowly rises and breaks through the crust. And that wasn't all. In 2024, another research team ran a new analysis. They used advanced image processing to scan thousands of Magellan radar images, looking for similar changes. They didn't find one. They found several. More vents had shifted. Some were now misshapen. Others had deflated, as if magma beneath them had drained away. In places like Sif Mons, Sapis Mons, and Niobe Planitia, there were signs of recent flows. Cracks, domes that looked like they'd caved in, features that didn't match earlier scans. Again, this wasn't atmospheric distortion. These were real, physical changes to the surface. And that meant only one thing. Venus is still geologically active. But what does that mean? For one, it explains Venus's strange atmosphere, the thick layers of sulfuric acid, the mysterious UV-absorbing particles, the fluctuating levels of sulfur dioxide. If volcanoes are still venting gas, they could be fueling the atmosphere in real time, shaping its chemistry, driving its climate. Some scientists have even proposed that recent eruptions could explain a controversial signal detected in 2020, a possible trace of phosphine in Venus's upper atmosphere, a gas that, on Earth, is strongly linked to biological processes. The phosphine finding is still debated. It might have been an error, or it might mean something more. But one thing is certain now. Venus is not a silent world. It's not a dead rock floating in the void. It breathes, it shifts, it erupts, and it's doing it under a crushing sky of acid and fire. And soon, very soon, we may catch it in the act, because NASA and the European Space Agency have missions planned. New orbiters with high-resolution radar, spectrometers, thermal imagers. They're being built to watch Venus in real time, to catch an eruption as it happens. Not guess, not compare. Watch. If they succeed, it will be the first time we've witnessed live geological activity on a planet we once thought was lifeless. And if Venus is active now, then what else might be happening beneath those clouds? When people look up Venus online, they usually find the same thing: beautiful, colorful images, swirls of orange, purple, and yellow, glowing like a painted marble. But those aren't real. They're visual interpretations, filtered composites, or artist illustrations. They look stunning, but they're guesses. The real images of Venus tell a very different story, one that's much harder to look at. The black and white photos from the Soviet Venera missions are raw, distorted, and strangely angled. You can see the edge of the lander in some shots, metal arms, or the curve of the camera housing. But what stands out is the ground, pale, cracked slabs stretching out under a thick haze. The terrain doesn't look alien in a science fiction sense. It looks strange because it's real. and your brain struggles to make sense of it. The surface appears fractured, uneven, as if it's been broken and pressed flat under immense weight. That's not an illusion. Venus's pressure is over 90 times what we experience on Earth. Materials compress, deform, and settle in ways we don't fully understand. The rocks might have once flowed as lava, then cooled and fractured like a baked crust. Then there are the colors, mostly from Venera 13. They're not natural the way we think of color photography. These are images filtered through a yellowish atmosphere, affected by extreme heat and strange lighting. The sky has a sickly, sulfuric tone, while the ground leans toward muted browns and yellows, like scorched clay. None of these visuals were captured easily. The landers didn't have long to survive. In less than an hour, the heat, pressure, and corrosive atmosphere destroyed each one. But in that short time, they gave us the only direct visual evidence we've ever received from Venus's surface. Magellan's radar maps offer a different layer. They don't show light or shadow. They show structure, elevation, texture, form. The radar pulses reveal the outlines of massive volcanoes, deep valleys, and strange formations with no Earth analogs. Some surfaces reflect strongly, indicating roughness or perhaps different mineral compositions. Others appear dark and smooth, like ancient lava plains. Then came Parker. For the first time, we saw a glow, actual light, emitted from Venus's surface itself. It wasn't bright or dramatic, but it was real. You could make out the shape of highlands, the curve of ridges, and subtle changes in elevation. Not in perfect detail, but enough to know this wasn't just theory anymore. We were watching a world reveal itself. When you put all these layers together, Venera's surface photos, Magellan's radar maps, Parker's visible light, you begin to see Venus not as a mystery, but as a place that's harsh, damaged, and still largely unknown. The images don't come to us clearly or easily, but they come, and each one brings us closer to understanding what's really happening beneath those clouds. The beauty of these images isn't in how they look, it's in what they mean. They're not made to impress, they're made to reveal, and they reveal a planet that refuses to be simplified. Venus wasn't always like this. It may have once had oceans. It could have looked like Earth, same size, same gravity, same position in the solar system. But something happened, something so dramatic. It turned a potential paradise into a planetary inferno. We still don't know exactly when it changed or why, but every image we've uncovered, every scan, every signal is a clue, not just about Venus, but about us. Because the real story of Venus isn't just about a distant planet, it's about how fragile a world can be, how quickly it can turn, and how much we still have to learn before it's too late.